Okay, so the next example that we're gonna do is going to be another trust so that we get a little bit more experience with this process, starting out and then doing each one of our members. But this one is arranged a little bit differently. So the trust that we're gonna be looking at is here in the first figure. And you'll notice that they have, the triangles that we see, but this time, instead of having the supports on the bottom of the truss, it's supported on the side. Okay, that's the only difference here, but it's still considered and it's still going to be done just like we did the last truss problem. So first things first, our process is going to be draw a free body diagram of the truss that is all together. So on our page 5 in our guided notes, you'll notice that there's a place here to start example 6.3. I'm going to put this back underneath here for those who are maybe at home or don't have the PDF in front of them at the moment. And then I'm going to draw mine over on the side, and then we will work on this together. Making sure that you put any applied loads and then also represent your reactions at your supports. Don't forget you to put your convention. Yes, F is just a roller. Yep. And what I'm gonna do. Line underneath. I did not put my reactions at F and at G yet, but I did put like everything else, if you would, in their spots, including my convention. Now, as we look at F and at G, you'll notice F is a roller and G is a pin. So F is going to be perpendicular to the surface it's riding on. The surface is vertical, so the pin reaction is going to be horizontal. Okay, horizontal. So this is going to be my F. I'm going to call it X because it's horizontal, and I'm going to assume a direction going to the right. Okay. Then what I'm going to do up at G is a pin, so we know that a pin always has an X and a Y value, so I'm going to have a GY. And then because I assumed FX going to the right, I'm going to assume GX going opposite. Okay. So now our only unknowns when we have the truss together are going to be the reactions. So I've got FX, GX, and GY. So knowing what you know about our equations of equilibrium, including the sum of the moments now, because here we don't have a concurrent force system. We've got some offset distances and forces that are going to cause rotations. Use your three equations of equilibrium to solve for those three unknown forces at the reactions or at the supports. Okay, so go ahead and do that. That's our first step. So you should get GY 15 kips. I ended up with a positive answer, so the direction I assumed is correct. Then I summed my moments around G to solve for FX, 23.09, positive answer. So the direction I assumed was correct, so it stays that way. And then I summed my forces in the X to get GX. Okay, and again, positive answer, so it confirmed the direction I assumed. So I have GX as 23.09 kips. I've got FX at 23.09 kips. And I've got GY at 15 kips. Okay. You don't have to put them back in there, but kind of nice when you look back and you do the joints, you know what they are. Any questions on determining the reactions at the supports when we have the truss as a whole? Just wanted to confirm. I couldn't remember if I started the recording or not. Okay, then if we're all set here, we're ready to jump in and look at each one of the joints separately. I'm going to start at joint G. Okay, start at joint G. So we're going to draw everything that we know here, and then we're going to draw the members at the angle that they're coming from. I'm going to turn this over. Joint G. And I'm going to start here. And I have my GX, I know is going to the left, and it's 23.09 kips. Okay. I'm not going to label it GX. I know it's that magnitude and it's pulling away. I also know that there is a vertical force going up. And I know this is 15 kips, and that's my GY. Then I've got a connection over to the member E, or to point E. So this is going to be called GE. And then I've got a connection down to D. So this is going to be GD. Now, as we look here, GD is at an angle. We know it to be 60 degrees, okay? But I'm going to put in here representing my X and my Y components. So this is going to be GDX, and this is going to be GDY. Now I need to put arrowheads on here. As we look, there are only two forces in the Y direction. Since my GDY is an unknown direction at this moment, but I know the 15 is going up, which way should I show the GDY? Up or down? What do we think? Up or down? Yeah, down would make sense, because if I only have one other Y force, it's going up already, and I know that to be, its value, then it has to go down to keep it in equilibrium. Now, if this Y is going down, do you see how my GD has to go down and to the right? So my X has to go to the right. Okay. I'm pretty certain about GD. But GE, we have 23.09 going to the left. I've got GDX going to the right. I don't know its magnitude. And then I've got GE. Which way should we show GE? Pulling away or pushing on? Left or right? Pulling away? Okay, we'll do pulling away. And again, it's exactly that. I'm not exactly sure myself, so I need to just assume a direction. Okay, so now before I get too far, I'm going to identify my GDX. Well, I know that this is at a 60-degree angle, right? And I haven't, on the last problem, I know that angle is going to keep coming up. So I need to determine what its value is going to be here, right? So I know that this is 60 and this is 60. So my GDX is going to be the cosine of 60 degrees times GD. Okay. So that means that GDX, I do 60 cosine, that's going to be 0.5 times GD. So whenever I have a cosine now, it's going to be 0.5 because of the 60-degree angle comes up on all of the triangles throughout. And then my GDY is going to be the sine of 60 degrees times GD. And if I take the sine of 60, I'm going to get 0.866 times GD. Okay. So these two I'm going to use for my GD, but whenever I have an X component from now, it's going to be times 0.5. And then the Y is going to be times 0.866. Anybody have any questions about that? Okay. All right. Now that I have that figured out, I can use my equations of equilibrium. Since my Y only has one unknown, let's do the Y first. So I'm going to sum my forces in the Y direction equal to 0. I've got a positive 15 kips. And I've got a negative GDY, so a negative 0.866 times GD. Okay, so this is my GDY equal to 0. There's only those two forces. So I'm going to move my 15 to the other side. I have a negative 0.866 times GD equal to negative 15 kips. They both become positive. And then I'm going to divide both sides by 0.866. GD equals 17.321. I'm going to hold that extra one, kips. Now, before I put GD away, am I in tension or compression? Tension, yep. It's pulling away from the joint. So that's going to be in tension. Here we go. Now I can put a box around it. My other unknown here is GE. So I need to do my sum of my forces in the X direction equal to 0 and solve for GE. So I've got a negative 23.09 kips, positive GE, and a positive 0.5 times GD, which I know to be 17.321 kips. Okay, so that's right there. And since I'm in the X direction, it's multiplied by 0.5 equal to 0. So now I can combine these, right? Multiply them out, combine them, and then solve for GE. So GE minus 14.4295 kips is equal to 0. I'm going to put that to the other side. I'm going to say GE is equal to, I'm going to go 14.43 kips. I don't need to hold 4 decimal places. And it's a positive value, so the direction I assumed was correct. So Chris picked going away, so that was good. And if I would end up with a negative, as we know, we would then have to go up and change the direction here. That's it, okay? So the negative isn't a big deal, but you can't leave it as a negative. Since we're pulling away, this is tension or compression? Tension, that's right. Okay, getting the hang of it. Now we're ready for our next joint. That sounds weird.
Yeah.
Okay, the location, our next location. So we did G, right? Where do we want to go next? Sure, let's go to E. Let's go to E. See what happens. Can I get E down here? I think I can. Okay. Joint E. Joint E. Here's my E. I've got one going over to C, going over to GE. This is point E. And then I'm connected down to D. So I'll have ED, EC. And this is GE, right? And I know that to be 14.43 in tension. So if it was in tension up here, it has to be in tension over here. So it's going to be pulling away from E. And I know that to be 14.43 kips. Should be closer. Now, since that's going over to the left, then that means EC, it's the only other force, it's gonna have to go to the right. And then ED doesn't have anything opposing it, so I'm gonna show it going up. It really doesn't matter if I'm going up or down. So to solve for EC, some forces in the X because it's a horizontal force. I've got negative 14.43 kips plus EC is equal to 0. Move this to the other side. EC is equal to 14.43 kips. Positive value means the direction I assumed was correct, which I was pretty sure about. And it's pulling away, so this is in tension. Box around because this is one of my answers. I need to determine the force in that member. And then we solve for ED. Sum the forces in the Y equals 0. I've got a positive ED, the direction I assumed, equal to 0. That's it. It's a 0 force member. So it's neither tension or compression. And if we would literally take it out, be fine. Isn't that kind of weird? I know. And that happens. It happens. Okay, any questions on joint E? So now we did G, we did E. Where do we want to go next? D. Sure, let's go down to E. Let's go down to D. So on my next page here, D is at the bottom. So I'm going to show going over to F, up to G, up to E, up to C, and over to B. It's another busy point. So joint D. Now I did have D connected up to G. So I'm going to go back to my joint G. And I have GD in tension pulling away, and its magnitude was 17.321. So that means this is going to go up and to the left. I'm going to leave the units off right now. It's kips is going to add, and it's going to just get in the way. So I have a little note here that my units are kips. I don't want to break my rule, but I need a little bit of room. So I know that is pulling away, going up and to the left. It's going to have an X and a Y component that are going up and to the left. So knowing that this is at that 60 degrees, and I know that 0.5 times GD is going to be my X component, and 0.866 times GD is going to be my Y component. So I'm going to take that 17.321, and I'm going to multiply it first by 0.5 for my X component, and that's going to be 8.6605. And then my Y component is going to be 0.866 times 17.321. That's going to be an even 15 kips. Okay, so again, I'm just keeping the kips off right now because there's just not room there. but I have a little note. I don't want to forget about them. And then I'm going to add my X and my Y's here. Okay. And then we'll kind of decide, we'll kind of move around and decide if we can figure out directions. So any questions here? This is all from GD, right? That's from GD. So it was intention pulling away, and I put the X and the Y components in their actual magnitude so we can include them in the equation right away. So as we look here, we know that ED is 0. So there's not going to be an arrow on that one. You could actually take it out if you wanted to. I wanted to represent it, but it's not going to be included in some of our forces in the Y. It's just 0. So really the only other Y is going to be DC. So if we know that this 15 is going up, do you see that DC needs to go down, right? In the Y direction. So this is going to be our DCY. With that going down, then that means that our DC has to go down and to the left, and then our X has to go to the left. Okay. Now we can say DC X is equal to 0.5 times DC, and DCY is going to be 0.86 times DC. Again, because of the 60-degree angle being in that standard spot. Now, I've got an unknown here in the X, unknown here, and an unknown here. This kind of becomes a crapshoot, okay? We just have to determine distances because in this case, it's not obvious. So I'm going to assume my DF going to the right. And no, because remember, there's a joint F over here. So this is a member connecting D to F. And then at F, then we're going to be figuring out what's going on there. Does that make sense? Josh, you're going to be right because it transfers through, but it is a joint because there's a member there. So we should go back and do a joint F. Does that make sense? Yeah. It'll be a little short one. So right now I'm going to just assume that direction there. And then I'm going to assume my DB going back into the left. Again, assuming if we end up with negative values, we know we're going to have to do a little bit of switching around. So as we look here, is there any direction that we can try to solve for? Meaning, is there any direction X or Y where there's only one unknown? There is. So we can sum our forces in the Y direction equal to 0. We've got a positive 15. Make sure to add your kips there. We've got a negative DCY, which is 0.866 times DC. Okay. And that's it. Those are the only two in the Y direction. I can set that equal to 0 because ED is 0. So you don't need to include it there. So now I can solve for, I can put my 15 on the other side. Negative 0.866 DC is equal to negative 15 kips. They become positive on both sides, which is good. Divide both sides by 0.866. And my DC becomes 17.321 kips. Now, I got to look back up here. DC, we assumed pointing towards D. So that means that it's in compression. So I can put a box around this one. Okay. Now I'll sum my forces in the X direction and see where I'm at. Okay. So I've got a DF going to the right, positive. I've got a minus DB coming back to the left. And then I've got a minus DCY, or I'm sorry, DCX. So I've got a minus 0.5 times DC, which I know to be 17.321 kips. equal to 0. So I'll, oh, thank you. Yep. I don't want to forget about that. Thank you, James. Minus 8.661 kips. Thank you. Equal to 0. So now I can multiply this out combined, right? So 0.5 times 17.32. So I'm going to have DF minus DB minus 17.321 kips is equal to 0. Moving that to the other side, DF minus DB is equal to 17.321 kips. That's as far as I can go though, right? 2 unknowns. And I don't have another equation that has the same 2 unknowns. So we'll just let that sit like we did on that last example. No worries, we can always come back to it, but we need to either find DF or DB. So if we go back to our original diagram, we kind of got stuck here. So it's probably worth our while to go over to F and see what's going on at that joint. There's not a whole lot, so that'll be a quick one, but we need to take a look. So we're going to draw joint F. Okay, joint F. So F, just like that. Grab my straight edge. Now, according to my free body diagram, we have that reaction at the roller going to the right, Fx. That remains in its same direction. This is not a member. This is a reaction at a support, so it's an applied load. So it stays right in its direction, and its magnitude is 23.09 kips. Okay. This is F. And then on the other side, this is what's going to connect F to D. And this is a member, and it's going to have to go to the left. So we can see that if we sum our forces in the X direction equal to 0, we've got a negative 23.09 kips. I'm sorry, a positive 23 going to the right, a minus DF is equal to 0. DF is going to be equal to, comes positive 23.09 kips, and it is going to be pushing on F. So it's in compression. Okay. Now we know that we can go back to our previous joint, which was joint D, and we can now put DF as a compression member. We did show it in compression, and we know this to be 23.09 kips now. Okay. Now, the good thing is we assumed it going to be in compression, going to the right. So we don't have to change any signs down here. Okay. So now all we have to do is substitute the value of 23.09 kips in for DF. So this is going to be 23.09 kips minus DB is equal to 17.321 kips. Now I'm going to put this to the other side. And I'm going to get a negative DB. It's going to be equal to, this is going to be negative on this side. So this becomes negative as well, right? Because it's going to be more, it's going to be 5.769 kips. 2 negatives become positive. So the direction for DB is still going to the left. Its magnitude is 5.769, and it's going to be in compression. Yes. There we go. Okay, now we're ready to go to our next joint. Come back to our free body diagram. We did GE F and D. Where do you want to go next? Any ideas? The next place we would logically go is something that's connected. So we already went up to E, right? So it's either C or B. Want to do B? Sure, let's do B. So joint B. Okay. Now joint B here. B has that 5 kips going down. Don't forget that. And then we have, this is joint B. There's a connection up to C, right? One going over to D. So this is DB. This is BA. And then this one is CB. So going over to D, up to C, over to A. So we already did D. So we can look back to see what DB was. DB was 5.769 in compression. So that means that it's going to be in compression on B. It's going to go to the right. 5.769 kips. So logically, there's only one other X directed force, right? Should go to the left. So BA should go to the left. We'll find out. And then we didn't do C yet, but there's only one other Y force, right? So since we have 5 kips going down, should have CB going up. So go ahead and solve for BA and CB. So you should get BA or AB, however you want to call it, 5.769. It's pointing towards, so it's going to be in compression. So make sure you include that in your answer. And CB is pulling away, and it's going to be 5 kips. So that one's in tension. Right. Moving right along. Any questions? All right, then if we look over here, we've gone all the way around. We have B. The only two that we have left are C and A. Let's go up to C. Let's go up to C. C is another busy one. We're going to go over to E, back down to D, to B, and then over to A. I'm determined I'm going to get it in here. Joint C. So E, E, C, E. We seem to know everything except CA, right? So I have looked back at all of my joints, identified my tensions and compressions. So if it was in compression and pointing at the other joint, then it has to be in compression and pointing at this joint. So EC was in tension, pulling away, so it has to pull away from C. This was CD. It was in compression, 17.321. So this was, I think we called it DC. Pointing towards, so that means that the Y has to go up, the X has to go to the right, 15 and 8.661 for each of those. This was CE. It was in tension, 5 kips, pulling away from E, so it has to pull away from C. So in this case, it's going to go down. And so now I just have my unknowns over here. So as I look at the numbers, I'm going to look in the Y direction first. I've got 15 going up right now. I've got 5 going down, and I've just got my CAY. This needs to go down as well, right? I've got extra going up right now. So this one needs to go down. And then you're going to notice that in the X direction, this is going to have to go to the right, because then CA is going to go down. But let's kind of look. I've got 14.43 going to the left. I've got 8.661. So yeah, it makes sense that my CAX has to also go to the right. So go ahead and solve for CA. And I'm going to put this up here. My CAX has to equal 0.5 times CA, right? And my CAY has to equal 0.866 times CA. X's. I so wanted to get it on here. I am. Oh, I didn't have to solve. Oh, yeah. So we should get 0. Just checking my numbers. I should get zeros here, but I'm a little off. Do you guys have different numbers than me? Minus plus 0.5, 11.5. I'm getting negative 0.57, I'm sorry, negative 5.769 kips plus 5.7737 kips. I think it's just a rounding error equal to zero, because this should equal zero if I'm adding and subtracting those, because it's just I was just doing a real quick check. You don't have to do that, but did you get 11.5473? Yeah. It must be, I'm thinking that the 14.43 is a little bit rounded. That's okay. You don't have to do this check. I just did it as a little separate. Okay. So now we're ready to go to our last joint, A. And our hope is everything is known and everything equals zero. So let's go ahead and draw our last joint, A. And if we go back to our original diagram, A has the 10 kips coming down. So we have to include that in that direction. There's a connection over to B and a connection up to C. And then for my X and my Y, I know my X is times 0.5. So if I take 11.5473 and I multiply it by 0.5, see, it's off a little bit. I don't know why my last one came out. I must 5.774 kips. And then my 11.5473.866 times. That one comes out right on 10.0 kips. These two are a little bit off. They should be closer. I get 4. Oh, I know. It looks like I did round this to 11.54. I wonder if that's 54.5 times. Yeah, that would be 0.577. So yeah, it's just a little bit of a rounding that I must have done. So it does come out. So now if we sum our forces in the X direction equal to 0, we'll notice that, and I'm not going to do the summing, I have the same amount going to the left as I do to the right. And if I sum my forces in the Y direction, these definitively come out zeros. So we must have done it right. Okay. But before we leave this problem, I'm going to one more time demonstrate MD solids. Okay. So that you can see how you would set this one up there. I'm going to go over, going to minimize this. And I'm going to pull up my MD solids. Now, something I'm going to let you know about MD solids. Again, it's not the most sophisticated program, and it's kind of old compared to just where we're at in Windows. If you read the little bio, The gentleman passed away, I believe, in 2013, 2014. It hasn't been updated since then. So it's 10 years. Okay. But it still works on the, the Windows updates. And you're going to find that it's a really nice, straightforward program to work with. Okay. It doesn't have a really pretty interface, but it's very easy to use. So I'm going to go back in, and what I was trying to tell you is I always, when I start a new program, when I start a new problem in MD Solids, I back all the way out and close it and go back in. Sometimes it might just stick with some of those numbers. So it's just good to it's a good way to refresh it. So I'm going to start a new truss again. And this one had 1, 2, 3. And there were 4 here and 3 sections, but they were 4 feet wide. And then my height is 6.928, and it's only 1, and I can hit OK. Now what I'm going to do is I'm going to add my members. I'm going to start at G, left click, and I'm going to release, left click, release, and so on. Again, don't go all the way across because they're not continuous members. They have joints at each one of the connections here. Now, if you put the one over here, it's considered an unstable because there's not a pin here, there's a roller. So what you want to do is that force, as we saw, moved right through that member. So we're going to actually add the support down here. So now that I have all my members in place, I'm going to switch to supports, and I'm going to do a roller support in that direction right there. Okay. If you, like I said, if you add this one, it's going to say it's unstable, but then you have to put it right there. Then I'm going to do the same thing over here. Then I'm going to switch it so it goes to a pin. Then I'm going to add my loads. And I had 5 kips going down. And I had 10 kips going down here. Enter load. And I think that's it. So I can hit compute. And you'll notice that it comes up with our values, no units, but tension, compression. And if you check all of our values, you're going to notice that the very same thing came out. So again, when we look at our homework, I suggest doing this first for the one that you're going to have to do manually. That way you've got an answer key as you go from joint to joint. Okay. So any questions right now? Say that again. Yes. Yes. And we'll look at that in just a little bit. So I'm going to open up my camera one more time. So as we look here, the guided notes that we have for the truss. So the first section here. There are 2 guided note packets for this module. So don't upload them just yet. Do them as 1 practice problem, but 2 handouts. So this is the first one we got through tonight. The next time we're together, we're going to get through the second one. So if you wanted to print those out, I'll bring copies to class next time. But hold on to these right now before you upload those for your practice problems, because there'll be another packet to add.